Hi, I'm Ken Cook, and I'm having another episode. I've spent decades, really 50 years, in environmental advocacy. I know it's hard to believe from my dewy, smooth complexion. Oh wait, my producers are. Oh, no, that's fair. The script actually reads dented, sagging complexion. So as you can tell from my dented and sagging skin, I've been at this for quite a while, and I've observed a disturbing pattern during this time. Our early warning system, for example, for environmental hazards, toxic chemicals, rarely comes from where we might expect and hope it would come from. It's not rigorous government oversight, checking to ensure we're not surprised by dangerous exposures. It's not industries with deep scientific capacity and technical expertise like the $1.1 trillion plastics and petrochemical industry with its hundreds of thousands of scientists and engineers voluntarily stepping forward when they discover a problem. That should be how it works, but it never does. Instead, it goes a little something like this, like DDT, synthetic pesticide that was used from the 1940s to the 70s when it was banned to control insects and farm pests. It was discovered in wildlife because a university professor, not the government, not the company who made it, a university professor who happened to be a birder also happened to have a laboratory that could analyze bird tissue, and he found it. PCBs were identified when a scientist who was studying DDT noticed a strange blip on his oscilloscope, which turned out to be Monsanto's PCBs showing up in his samples of wildlife. Hexavalent chromium. That came to light because my friend Aaron Brockovich, who was our very first guest on this podcast, not a chemist, not a scientist, not a lawyer, asked tough questions about water near Hinckley, California. A government inspector stumbled upon the contamination featured in a civil action because he got curious about some barrels of waste. That's our frontline defense. Accidents, happenstance. PFAS forever chemicals followed the same pattern. Companies like DuPont and 3M knew for decades that PFAS substances were in workers, wildlife, human blood. They didn't tell anybody. They weren't even obligated to disclose to the government or the public their methods for detecting these chemicals in human tissue or the environment. And the same is true of microplastics and nanoplastics, our topic today. This is the sort of latest hazardous wave that's hitting us in terms of our recognition of it, even though it's been happening for decades. These breakdown products of our massive plastics economy didn't even have a name until around 2003 or 2004 when a marine biologist coined the term microplastics. The industry has built plastics molecule by molecule for over a century. They know what happens when these materials break down because that's how they built them. Yet our first line of defense, again, has been independent scientists who got curious about something that didn't look quite right. And at the forefront of this is Dr. Matt Campen, my guest today. He's the director of the New Mexico Center for Metals in Biology and Medicine and Regents Professor at the University of New Mexico. One of those scientists who looks where maybe the petrochemical industry wishes he hadn't looked, but he does it because he's a scientist. What began as a 7th grade science fair project with Matt's son, collecting water samples from the Rio Grande to look for microplastics under a simple microscope, has evolved into pioneering research that's both illuminating and controversial. And this is from an expert who spent years studying the impact of very fine particles of air pollution on our health. Campen's recent study finding microplastics and nanoplastics in human brain tissues sent shockwaves through the scientific community and the public, but it also triggered a predictable response: industry pushback. A Guardian article questioning the validity of microplastics research featuring critiques of Matt's methods and highlighting scientific uncertainties exemplifies the kind of resistance that often emerges when independent research threatens established economic vested interests. Without government oversight or industry transparency, scientists working on shoestring budgets relative to industry at independent universities are often our only early warning system. Those scientists are the ones asking the tough questions that a $1 trillion plastics industry won't ask and that a weakened EPA can't pursue. Maybe the EPA should think about living up to its name, and maybe the $1 trillion plastics industry should focus on real, transparent science and disclosure instead of corporate subterfuge and attacking independent scientists who are sticking their nose in the plastic industry's business. Matt, thank you so much for being here. I'd love to start with how your microplastics journey began.
Well, Ken, thanks for having me on. It's a great chance to share some of this research and some of our story. My entree to this world was as a skeptic. There were a lot of studies coming out since about 2004. Richard Thompson had this
Yep.
seminal paper, and I came from a background where we studied the little particles in air pollution that arose from diesel exhaust, coal combustion, and typically in the lab, in our toxicological studies, we would use little polystyrene plastic particles as a sort of a negative control. So, in fact, a lot of my perception of big studies coming out about these global I was like, "Psh, who cares? They're inert."
I buy them for my lab work.
Right, right. And so probably 2015-ish, fully 10 years of great studies being done by groups, and especially in Europe, in Australia, and me sitting there like I don't care. I realized this is just building up in the world, and the central premise of toxicology is dose makes the poison. So even the most neutral substance on Earth I can think of is like nitrogen gas. We breathe air that's 70% nitrogen gas, and who cares? But if that goes from 70 to 90%, well, then you have a problem because you don't get oxygen. So even if it's just that plastics are so ubiquitous that they're displacing other things, there could be problems. So I started getting interested, and my son, we had to figure out a middle school science fair project. So we just decided we would do some basic collections of water in the Rio Grande, which is the main river source for New Mexico.
Yeah.
We sampled from basically the headwaters of this river, and then again in Taos, and then working our way down to Albuquerque, where there's now 1 million people contributing to the watershed. And you could see, using 7th grade science, that there were plastics in the water, and they went up in concentration as you move down the river.
So, what was the 7th grade science? Let's put the lab coats on
Sure.
these 7th graders. What were they doing?
Sure. This was as simple as we had a nice light microscope. Yeah, he had help from dad. We turned off the lights and we shined a black light. So we're looking for fluorescent particles in the water, and we also let the water settle. So anything heavy that might be like calcium, mineral crystals, or rocks, they would settle down. And so we took the top layer off of these. We collected in glass containers and things like that. We ran it across a filter and then shined the fluorescent light on there, and we'd look for things that would fluoresce. And my kid sat there and counted them, used a little clicker, and 1, 2, 3, 4.
That sounds like something a $1 trillion industry with hundreds of thousands of scientists could do too.
I We're open to conjecture. I like it. Then the irony of his experiment was that was in the fall of 2019. By the time he put the poster together and was ready to present in the spring of 2020, all of the science fairs were shut down for COVID.
Yeah.
So he never got a chance to present this work. But we've actually used that data in a number of grants to the National Institute of Health. So
Oh, I love it.
then we started scratching our heads in the lab, and we did some basic studies where we started with the standard polystyrene microsphere that everybody starts with. It's wrong, but all models are wrong. Some models are informative. So we thought, well, look, these particles are in the environment. They're exposed to ultraviolet light. Let's just incubate them for like 4 weeks under a black light, a UV light, and see if that changes enough of the surface chemistry that it alters the biological interactions. And we used some cell culture techniques, and it did. It very clearly made a difference that the surface of these plastics was now aged and degraded, seemingly made it more toxic. And we stopped at that point and said, We don't know what's in the human body. We don't know what the right dose is. We don't know what the right particles are. We don't know what the right polymers are, size of plastics. What are we doing? And that made us, as a group, we said we've got to get hold of some human tissues and really try to find these and see what they look like. Another key ingredient in all this was we had a postdoc named Marcus Garcia, and Marcus was a pharmacist. He had a PharmD background, and so kind of thinking in terms of that nanomedicine world where they actually take
Yeah.
polymers like PLGA or PLA and package drugs in little
Yes.
little tiny nanospheres specifically to get them across the gut and to the brain. It kind of gave us some inspiration from that parallel universe to say maybe there is a mechanism that drags small enough plastics into the body. We started reaching out to our Office of the Medical Investigator to ask, did they have some tissues from humans, from autopsy specimens, just so we could
Yeah.
start exploring. And we looked at methods for measuring and detecting plastics, and we knew there was a fundamental gap between what had been done in the environmental world, the oceanographers and
Yeah.
ecologists, and what was relevant to human health. And the gap is that most of the really strong methods for detecting plastics depend on vibrational spectroscopy, so Raman or FTIR. And those systems really don't work for particles smaller than 5 micrometers. There are new systems that are pushing us a little bit better in that direction. There's great technology out of Colombia, Beijing. I mean, we're moving in a better direction. But at the time, 5 micrometers was sort of this limit in the technology. And the problem there is our bodies don't really care about anything larger than 5 micrometers. They don't absorb well. In fact, for air pollution, we have a thing called PM 2.5, which is
Right.
particulate matter that is smaller than 2.5 microns. So
Hmm.
automatically, from my world of air pollution, I'm geared towards not caring about such large particles. So we recognized there was this fundamental gap, and we needed something that would more cumulatively collect and analyze the nanoscale fraction, the stuff that's 50 nanometers to 1,000 nanometers. So we decided mass spectrometry would be the way.
Hmm.
We tried a couple different approaches and settled on, a number of groups were publishing with pyrolysis, gas chromatography, mass spectrometry. We made an investment. It's not a perfect solution, but it's an informative solution. All models are
Right.
wrong. Some models are informative.
And it's 2020, and it's not exactly the dawn of the plastic era.
Right.
So that's the thing that haunts me that I want people to really take away from our conversation is that this is something that we're coming to very late in the plastic economy. And we're coming to it not with the full strength of an industry that is pursuing and divulging, disclosing, being transparent about what it knows and what it doesn't. So here you are at the University of New Mexico trying to pull together grant money to buy equipment and get people out on the edge of an area that is risky professionally, and it's also risky because of the bear
Mhm.
you're poking.
Yeah. Yeah. No, all those things are legitimate factors. Depending on your perspective, the University of New Mexico, we say UNM stands for University of No Money. That said, what I love about this is we are in a lot of ways sort of a gorilla in the room. New Mexico has a really phenomenal health science center.
Absolutely.
Our College of Pharmacy is actually ranked third in the nation for research dollars. The other aspect of what I like about our institute is we're a right-sized institute, and we have reach to other departments, other colleges. So I can go talk to my buddies in the College of Engineering. I can go talk to
Yeah.
people in the School of Medicine, Public Health, and we have a very collegial atmosphere here. And when you're tackling something where there's no book written on this, it's clearly multidisciplinary: chemistry, physics, biology, biomedicine. We needed this kind of an institute where we could get a lot of people thinking about the topic.
Yeah. You needed an ecosystem. Labs all over the world are struggling with this, and they've come to it late. There's no legal limit, there's no regulatory system
Yeah.
that is forcing science in the direction of solving for these things because there's no legal limit yet for any microplastics or nanoplastics in any medium that I'm aware of, except in California. I guess they have some values for drinking water. But this is a global hunt to try and solve this set of questions that are really vital to how we think about this huge economy going forward that's built on plastic.
Yeah. All those things are absolutely true and things that sort of keep us awake at night.
Yeah.
But we just came out of this microplastics exposure and human health conference. I don't know why I was foolish enough to try to put this together, but it was the right time.
Yeah.
There's a head of steam. The EU has been focused on microplastics much longer. There's great resources there and great scientists already involved. But the United States, which should be leading the planet in biomedical research, is really late to the game. And so I think there was a zeitgeist, right? This was the right time. We needed to come together as a community, talk inclusively about all the challenges that we have and the potential solutions and opportunities. And, what I walked away with was one was like people are really engaged. We got all oars in the water kind of mentality. And there's a lot of corroborating evidence out there. So, you look at our paper and it's relatively easy to look at any one thing and poke a hole in, well, I don't know if I have confidence in what you've reported. And well, this method is known to have this problem and this method is not specific to plastics. You can take it apart as a forest for the trees kind of approach. But if you start looking at the new science coming out from different labs using different approaches and different models, there is evidence that these plastics get into our bodies, they accumulate in the brain. There is evidence that it is a nanoscale plastic that is critical. The truth will out.
Yeah.
More people getting involved will figure this out. And then the regulation will come.
Right.
I really do put this in a category akin to the Clean Air Act or the Clean Water Act. I don't know what river we have to set on fire to get federal regulations in place. But we need something that's more comprehensive. We do need something that does appreciate the economic drive for plastic materials. The Clean Air Act, it didn't destroy the automobile industry. It mostly just said all y'all got to use a catalytic converter.
Yeah.
And they did. And it wasn't an added cost because they pushed that off to the consumer. And decades later, we've got better air to breathe in this country.
Much better.
We took lead out of gasoline and blood lead levels in our populace has dropped 95% in the past 50 years. So there are solutions to the problems that can manifest from federal regulation, but Clean Water Act required the Cuyahoga River fire. So it's difficult to know what will be the lightning rod that sets up a bipartisan approach to something as dramatic as a Clean Plastics Act.
Yeah, I think that's right. And, we saw it happen with PFAS chemicals for decades. That information was the sole property of the companies that made the materials. They had done a lot of research beginning to understand its toxicology. And almost all the news coming back was really bad. And then when finally we got to the point where methods were available, a standardized method was available to find it in drinking water, you saw the levels that were considered safe drop pretty much year by year.
Yeah.
We're now at the part per trillion level legal limit in drinking water it's been postponed by this administration for a couple of years, but eventually utilities will have to make sure water delivered to customers isn't above that 4 part per trillion level. Very much lower than we started with when we were talking about parts per billion, which is 1,000 times more. If you're in the plastics business in any way, in any part of the $1.1 trillion value chain, you're not eager to have this regulatory regime stood up. You're not eager to have it necessarily measured in the environment. For the most part, there are people out there who are bothered by this and they want to make information available. They want to conduct studies. They want to monitor. They want to do the kinds of things you need to do to protect public health and the environment, but they're within an industry that's safeguarding its profit margins and is worried about its capital expenditures and how they're going to amortize those over time. And to do that, they have to keep producing the things the way they've been producing them and in the quantities. So there's lots of pressure back against it. And there are examples of this, whether it's PFAS or DDT or whatever, where there's a moment where the science starts to tip.
Mm. Mhm.
The strength of the science is overwhelming. You have the Clean Air Act, starting with concerns in California and elsewhere, where people are recognizing there are these very coarse and obvious impacts on people's health,
Right.
where you can't go outside. And so the research that begins to fill in and eventually leads us to the 2.5 focus, scientists begin to find out, hey, these particles really penetrate deeply into our bodies, into our
Mhm.
lungs, and they cause all kinds of damage there that we know in 2026 is much worse than we knew in
Yep.
2010, on and on. The science progresses and it eventually pushes this forward. But there was recently a controversial report in The Guardian
Mhm.
where scientists from a number of sources were making the case that suggesting that the scientific uncertainties that you've just described, the search is full of hits and misses, but the search is underway. But the impression that that report left, and we'll put it in the show notes so that people can read the story, was that, hey, maybe this is not a thing. Maybe they're finding things that aren't really micro or nanoplastics. Maybe this is kind of a false positive situation where it's been exaggerated for getting clicks or getting people concerned or scaring people. The scare economy is kicking in here, and so forth. Now, The Guardian walked it back to their credit with an editorial that a little bit. I'd love your perspective on that because you were mentioned in that article and your work was mentioned, I thought, very unfairly. What was your take on this? Because this is the reality for my listeners out there, whether it's Herb Needleman getting attacked by the paint industry
Mm.
for going after lead in paint, or Phil Landrigan for going after lead, scientists who've worked on DDT, even Rachel Carson, just as a journalist, scientists who worked on PFAS. There's no example of poking a bear like a big industry like that where you haven't had these moments where scientists have been questioned. And I think questioned in ways that I would turn it around and say, hey, why is it that the plastics industry doesn't have these standardized methods? Where you been? You've got all the money. You brag about hundreds of thousands of scientists and engineers. Show me your work. And it's not there yet.
Mhm. Yeah.
That's my editorial on it all. But what was your take on all of that, Matt?
Yeah. Well, obviously, when your science is criticized, there's certainly a visceral like uncomfort with it.
Yeah.
But it's a couple weeks in the rearview mirror now, and I'm looking at it, and the only thing that really bothers me about the report from Damian Carrington in the Guardian was the headlines, which were
Yeah.
bluster. And in fact, some of them were taken from LinkedIn quotes from a year ago, which I thought was not only unfair to the science, but unfair to the individual that was being quoted, because it took
Yeah.
their concerns sort of out of time and space. And I respect that different scientists are going to view this with their different philosophies and their different lenses. Analytical chemists have very little room in their philosophies for uncertainty. You transition all the way to the world of epidemiology, where, okay, if you want to measure something in 10,000 people in a cohort, you're going to hope that the measures that can be done efficiently on that many samples, carry some semblance of truth with them.
Yeah.
So we sit closer to the analytical chemists, and I appreciate where they're coming from, but at the same time, we do want to move this to assessing human health, and I can't spend 15 or $20,000 on every single sample, sacrificing a postdoc to generate data on three different, minute samples of plasma or blood. We have to bridge this divide somehow, and there will be sacrifices to the altar of uncertainty, and people will
Hmm.
always be uncomfortable with that. What bothered me about the article was it made it sound like there was something new, when if you go back and look at those
Right.
criticisms, we covered that in the caveats paragraphs a year ago. And so it's not new, it's just part of the discussion. The rest of the article outside of the headline, I thought was measured. Damian Carrington highlighted some important caveats to the way we do the science, and it is part of the scientific debate. And media is a double-edged sword, right? I thought it was overly blustery in a positive sense, when it first came out and everybody's talking about plastic spoon in the brain, which was an extrapolation you will not see in that paper.
Yeah.
The media leaned too far towards clickbait in the first place. And so for it to lean in clickbait in the opposite direction, like I said, it gnaws at my insides, but that's good for the science. We need to have these debates. And like I said, at this meeting, some good colleagues, and I would consider them friends, have very different stances on my work. And I get, heartburn from
Yeah.
their work as well. But we're all pushing towards better. We're all
Yeah.
trying to make the science more accurate, more meaningful, so that we can really understand what the potential concerns are for human health and disease. I never imagined in my career that I would be kind of a lightning rod, right? And I don't think emotionally I'm necessarily geared for it as much as I'd like to be, but here we are,
Yeah,
right?
that's right. I mean, it wasn't your design to be a lightning rod or to have clicks.
Right,
It was your it was
right.
your goal was to try and answer this really puzzling question that first popped up in a seventh grade science project
Yeah.
for you with your son. And so to me, I think the lesson for people is to understand we're at a phase in this inquiry, and there are lots of people, really talented people, who are approaching it in different ways, but everyone is basically saying, hey, where does all this stuff end up
Hmm.
when it breaks down? What's it look like? And if it's in our bodies, which it clearly is, the next phase is to understand, well, what does it mean? Now, I have to say, as an environmentalist, my question at these junctures is always, shouldn't we have known that before we got it in our bodies if it was going to be harmful? But hey, I'm also a realist, and I know that we have companies that make stuff and there's no limits to what you can make, or there's no rules about how
Yeah.
much of it can be in a body. So why wouldn't you come up with new polymers, new plastics that solve problems and make you money? But that means that the work that's being done by you and colleagues like you and labs around the world and who gathered at this conference, I wish I'd been at. I'm not sure I would have been able to follow it all, but I heard such great things about the excitement and the sense that we're on the edge of a field of science that's going to yield some important breakthroughs, even more important breakthroughs in just
Mhm.
the next few years, right?
Right.
It's that exciting.
Absolutely. Some of the talks that were given will become papers in a matter of months to a year, and I'm so looking forward to seeing how that impacts the science and our concepts of especially the nanoplastics.
Where do you think it goes next? I know there's a lot of interest in our state level science agencies and environmental agencies to try and understand what's going on here. They're going to be dependent, in addition to their own work, dependent on this confederation, I would say, of scientists working around the world, some in government agencies, in Europe especially, some in independent institutes, academic settings. What is your sense of what the next couple of years will reveal
Yeah.
about this area that you and your son stepped into?
I think the fundamental shift to understanding nanoplastics is critical. You've seen some papers come out lately. Ours obviously highlighted a potential for nanoplastics study of the North Atlantic and showing that there might be more nanoplastic than microplastic in the North Atlantic Ocean from Sophie ten Heitbrink. So there's new interesting data pointing in that direction, and it entirely makes sense from human health standpoint because that's what we would expect gets into the body. So now we need to figure out better technologies to see the nanoplastics because we're really stifled in that direction. Then once we have that, we figure out what is in our food.
Hmm.
We talk about how wastewater sludge absorbs 99% of the plastics, and then we take that sludge and we put it on our agricultural
Yeah.
fields because it's nitrogen rich.
And we got to get rid of it. Well, it's got to go
Right.
somewhere. Every mayor in the country,
It's
yeah,
got to go
is
somewhere.
thinking about that.
And it should be good for that, like that's an efficiency for, I mean, we need agriculture. We need food for our country. Are we just focusing micro and nanoplastics back into our own diet? So getting a better understanding of, the nanoplastics and how they move through the environment and into our agricultural system. I think those are the pinnacle research areas that need to be addressed probably in the next 2, 3, 4 years.
Mm-hmm.
And then on the same side, now we have tools to understand human health outcomes better. I mean, my little world of toxicology is going to really benefit in terms of having better understanding of the actual toxicant that we're studying. What is the size and shape and material? And now we can align that into cell culture, preclinical research that starts addressing, are there neurological outcomes? Are there cardiovascular outcomes? My study, Rafaela Marfella's study in New England Journal, they're associative. They definitely light a fire. And I hope that a lot of people are interested in finding out if they're really a causal relationship. But at the end of the day, both of us were using study designs that just say there's trends in the same direction between plastics and disease. So I think we're going to make a lot of progress in the coming years.
It's very exciting, and you've been very generous with your time. I'm so grateful that your son had an interest in science and got dad involved. And obviously, the two of you were a dynamic duo. Maybe he'll be on the podcast not too many years from now. And it takes gumption to step into the public square in this way. I've had the privilege of being associated with a lot of great scientists over the years who have stepped into some pretty big fights. And you've stepped into one here. There's no question about that. I'm so grateful that we have scientists with your integrity and your commitment and your perseverance to get to the bottom of these things, because that's what it's always taken.
Well, I appreciate that sentiment, Ken, and I appreciate this opportunity to have the discussion. So thanks a lot for having me on.
Thank you to Matt Campen for joining me today, and thank you out there for listening. If you'd like to learn more, be sure to check out our show notes for additional links to take a deeper dive into today's discussion. Make sure to follow our show on Instagram at Ken Cook's Podcast. And if you're interested in learning more about EWG, head over to ewg.org or check out the EWG Instagram account at Environmental Working Group. Now, if this episode resonated with you or you think someone you know would benefit from it, send it along. The best way to make positive change is to start as a community with your community. Today's episode was produced by the remarkable Beth Rowe and Mary Kelly. Our show's theme music is by Moby. Thank you, Moby. And thank you all out there for listening.